We want to differentiate y is equal to e to the power of sine 3x minus 2. Once again, we have a function of a function of a function. Let's look what happens to x. First it goes into the 3x minus 2 function. The result comes out and goes into the sin x function. The output from this is the sine of 3x minus 2. And this then goes into the exponential function, giving us our final result of e to the power of sine 3x minus 2. So we can recognize here that this is the third function, the outside function. So we'll deal with that first. We know that differentiating e to the x gives us e to the x, and therefore e to the sine 3x minus 2, the outside function, gives us e to the sine 3x minus 2. We need to multiply by the differential of the inside function, which is the sine 3x minus 2. When we differentiate sine, we know we get cos. So we multiply by the cosine of 3x minus 2. But once again, we have an inside function, the 3x minus 2. If we differentiate 3x minus 2, we get 3. So we multiply by the 3. Tidying this gives 3 times the cosine of 3x minus 2 times e to the sine 3x minus 2. Note here that if we call this f of x, the multiplier in front of the e is f dashed of x. If you differentiate sine 3x minus 2, you get 3 cos 3x minus 2. So this is of the form f dashed x times e to the f of x. It can be useful to spot things of this form when we do the reverse process. So when you come to integration of more complex functions, if you see something of the form f dashed x e to the fx, you'll know the integral is just e to the fx.